In this video, we'll be looking at the sine function and the cosine function and changes in amplitude and period. The sine function is shown, and we're going to be looking at equations in the form y equals a sine b theta, where the absolute value of a is the amplitude. That's going to be the distance from the midline to the top, to the maximum point, or the distance from the midline to the minimum point. For our regular sine function without any transformations, the amplitude is 1. B is going to be the number of cycles that occur between 0 and 2 pi. For our regular sine function without any transformations, one period begins, or one cycle begins at the origin, and then it has a hump that goes up, a hump that goes down, and back to the x-axis, and the period is the length of one cycle, 2 pi. Now the cosine function is very similar. The form of the equation is the same, except that the y-intercept is a maximum point rather than being on at the origin. So that's how you can kind of distinguish between whether you're dealing with a sine function or a cosine function. And then that cosine function decreases down to the axis, down to a minimum point, back to the axis, back up to a maximum. The amplitude for our cosine function is still 1. The period is still 2 pi. Here are some functions where the sine or cosine function has been transformed. So we're going to determine the number of cycles between 0 and 2 pi. That will be our b value. We're going to find the period, the amplitude, and then write an equation of the function. So for part A, the number of cycles between 0 and 2 pi, well, if I highlight a cycle, so starting at the origin, it goes down, then up, and back to where it started. That would be one cycle. Here's another cycle. Between 0 and pi, I have 2 cycles. So between 0 and 2 pi, there would be 4 cycles. So for part A, there will be 4 cycles between 0 and 2 pi. And that means our b value when we write the equation is going to be 4. In part B, find the period. The period is, we're always going to use the formula 2 pi over b to find the period of a sine or a cosine function. And in this case, we already found b was 4, so 2 pi over 4 equals pi over 2. So that period is the length of one cycle. And part C, find the amplitude. The amplitude is the distance from the midline to the maximum value, or the midline to the minimum value. Either way, in this case, the y-axis, every box or tick mark on the y-axis is half of a unit, so this amplitude is 1/2. And for part D, we want to write the equation of the function. So to write the equation of the function, we want to determine if it's a sine or a cosine function. This function is going through the origin, so it would make sense to consider it a sine function. But normally our sine function starts at the origin and goes up first, then down and back, and that pattern continues. This one, however, goes down, then up, and back to the axis. So that means we have a reflection about the x-axis. The sine graph is being flipped upside down. So that means our a value is going to be negative. So it's going to be y equals negative 1/2 sine. And we found b, it's 4, so sine of, 4 theta. Okay, here's one more example like that. In part A, we are finding the number of cycles between 0 and 2 pi. So I'm going to highlight my cycles again. If I start at the y-axis, it goes down and back up to the top. That would be one cycle. Here's another. So it looks like we have 2 cycles between 0 and 2 pi. For part A, we have 2 cycles between 0 and 2 pi. And again, that is our b value. For part b, the period, we use the formula 2 pi over b. And in this case, 2 pi over 2 gives us pi. So one cycle goes from, the length of one cycle is pi units. C, the amplitude, is the distance from the midline to the maximum value or the midline to the minimum value. That's going to be 4 units in this problem. And then part D, write the equation. So this time, if we look at the y-intercept, it's not going through the origin, it's up 4 units. So that means we're dealing with a cosine graph because the y-intercept is up at one of the maximum points. And we know it's not reflected because it starts up high at a maximum point rather than flipping upside down and having the y-intercept be a minimum point. So it's not flipped upside down, it's not reflected about the x-axis, and we're not going to make the a value negative. So we get y equals, the amplitude is going to be positive 4 because we have no reflection, cosine of b is 2 theta. Okay, and for the next question, in number 2 above, determine the values of theta between 0 and 2 pi where the maximum values, minimum values, and zeros occur. So we're going to look at where we have maximum values, minimum values, and zeros. So let's start with maximum values. Okay, so I'm going to just put some dots on my maximum values. And I want to figure out where those occur. So now we only want them between 0 and 2 pi because that's what it says. So I'm not going to consider that last one. So between 0 and pi, we have maximum values at theta equals 0, theta equals pi, and theta equals 2 pi. Now if this graph were to keep going, we would also have them at 3 pi, 4 pi, 5 pi, and so on. Minimum values down here at the bottom. So that point is right in between 0 and pi, so that's going to be half of a pi, or pi over 2. Pi is the same as 2 pi over 2, so each box on this x-axis represents pi over 2. That makes this tick mark 3 pi over 2. My next one would be 4 pi over 2, and then I would have 5 pi over 2. So my minimum points are going to occur at pi over 2, 3 pi over 2, 5 pi over 2, and I could keep going, 7 pi over 2, 9 pi over 2, and so on. But again, we're only going to consider the ones between 0 and 2 pi, so I don't need that last one. And it's only going to be at pi over 2 and 3 pi over 2. Okay, and then the last thing we need are the zeros. The zeros are the x-intercepts, so let's see where those occur. So I have 4 of them between 0 and 2 pi, and those occur in between, like if I look at my first one, it's right in between 0 and pi over 2. So it's half of pi over 2, which is pi over 4. So when I have, like, every little increment that's that size is going to represent pi over 4. Pi over 2 is the same as 2 pi over 4, and this next one would be 3 pi over 4. And then pi is 4 pi over 4. This next one is 5 pi over 4. And if I follow that pattern, pi over 4, 3 pi over 4, 5 pi over 4, this is going to be 7 pi over 4. So the zeros are at theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that pattern would continue if we went beyond 2 pi, but we're only doing between 0 and 2 pi. Now we're going to graph some sine and cosine functions. The important things to know are the period and the amplitude. So the amplitude is the absolute value of a, or the absolute value of -5, which is 5. The period is 2 pi over b. In this case, b is 1 because there's no number in front of theta, so we're just going to get 2 pi over 1, which is 2 pi. So when you graph these functions, you want to we're only going to sketch one cycle, so I'm going to put my x-axis kind of on the left-hand side. That's my y-axis. My x-axis in the middle. And then on the x-axis, you want to have 4 subdivisions or 4 tick marks. And the fourth one is going to be your period. So based on the size of my boxes here, I'm going to do every 2 boxes, make a little mark with 4 marks total. And that fourth mark is going to be the period of my function, whatever it is. In this case, the period is 2 pi, so I'm going to make my fourth tick mark 2 pi. Now, to label the other tick marks, I like to cut that, whatever my period is, in half and make that my middle tick mark. So half of 2 pi is pi, and then I cut that in half and I get my first tick mark. Half of pi is pi over 2. So every tick mark, the spacing of my tick marks are pi over 2 apart. So the first one is pi over 2, the second one is 2 pi over 2, which is pi, and then 3 pi over 2, and then this would be 4 pi over 2, but of course that reduces to 2 pi. I'm going to erase this. So now I have that x-axis labeled in increments of pi over 2. And on the y-axis, since my amplitude is 5, I'm just going to count by ones. So 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And then to plot the points, this is a cosine graph, so I don't start at the origin, I start either up or down. That negative out front is a reflection about the x-axis. So remember, our cosine function normally starts up, goes down, and then back up, but we're reflecting it, so it's going to start down, go up, and then back down. So it's flipping upside down. So my first point, instead of being up 5 units, is going to be down 5 units. And then I go back to the axis at my next tick mark, up to a maximum point, back to the axis, and then back down. And there's one cycle. I make it nice and curvy, no sharp corners. And there's one cycle between 0 and 2 pi. Okay, one more of these. The next one, two more, I guess. The next one, 4 sine of 2 theta. So same procedure. We're going to start by identifying the period and amplitude. The amplitude is the absolute value of 4, which is 4. The period is 2 pi over b, so 2 pi over 2 in this case, because that's our b, and that's pi. So now when I graph this, I start off the same way, my y-axis on the left, x-axis in the middle. This time my period is pi. So I'm going to make the same 4 marks, but my fourth mark is going to be pi, whatever your period is. So 1, 2, 3, 4, this is pi. Half of pi for our middle tick mark would be pi over 2. Half of that would be pi over 4. So each tick mark on this graph represents pi over 4. So my first one's 1 pi over 4, my second one's 2 pi over 4, my third one's 3 pi over 4. And then 4 pi over 4 is pi. Then on the y-axis, I'm just going to do 1, 2, 3, 4, 5 again. And -1, -2, -3, -4, -5. And I plot my points. So for 4 sine 2 theta, there's no reflection about the x-axis because our a value is positive. Our sine function starts at the origin. Since it's not being reflected, it's going to first go up to a maximum point at our first tick mark, back down to the x-axis, down to a minimum point, back to the x-axis, and that will be one cycle of this function. And it keeps going, but we're only doing one cycle. Okay, and then one more of these. Period and amplitude first. Amplitude will be the absolute value of -3, which is 3. The period, 2 pi over b, would be 2 pi over 2. Remember, when you divide by a fraction, you multiply by the reciprocal, so 2 pi times 2 over pi. And notice these pi's cancel in this one. So our period is equal to just plain old 2 times 2, which is 4. And now we're ready to graph. So I do my y-axis, my x-axis. And for my fourth tick mark this time, since my period is 4, I just do 4. So this one's going to be a little easier to label. The middle of that would be 2. Middle of that is 1. I'm really just going 1, 2, 3, 4. And then on the y-axis, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And we plot our points. This is a cosine function, so I start either at a maximum or minimum point. There's a negative in front of the a value, so it's reflected about the x-axis. So instead of starting up at 3, I start down at -3. I go back to the axis, up to a maximum point, back down to the axis, back down to a minimum point. Make it nice and curvy. And that would be one cycle. In this next part, you're going to solve some simple trig equations using either a graphing calculator or Desmos.com. And what you're going to do is you're going to put your left-hand side of the equation if you're using a TI-84, you're going to put it in y1, and you're going to put the other side in y2. Oh, but hold on. Instead of theta, you need to put x, because the graphing calculator doesn't want you to put in theta. It wants x. And then on the other side, or in y2, we're going to put just y2 equals 1.5. Or in Desmos, you can see I put both of those equations in. Y equals 2 cosine 3x and y equals 1.5. And y equals 1.5 is a horizontal line. And what we're going to find is, where do those two graphs intersect? And those x values are going to be our answers. Between 0 and 2 pi, if you want to, you can take this little wrench in Desmos and change your scale on your x-axis to be in radians. And to do that, I just put in pi for the scale. And then you can see that we have the x-axis labeled in radians. And so we only want between 0 and 2 pi. So all the points that, all I did was tap on those points, and or you could click on them with your mouse, and it gives you the coordinates of the intersections. So all of these x values are going to be the answers to that equation. All right, we're going to do the same thing for the next one. So I graphed each side of the equation in y1 and y2 if you're using a TI-84. Also, if you're using a TI-84, to find the intersection, it's a little more complicated than just tapping the point like in Desmos. On a TI-84, you're going to have to press second, trace, and then intersect or intersection, something like that. You choose that, and then it'll say first curve, question mark, and if you just have two graphs in there, you're going to press enter, because it'll be on, like, the little spider guy will be either on the line or the cosine function. It'll probably start off on the cosine function if you entered that first. And then it'll say second curve question mark, and you're just going to press enter again, and you'll notice that the little spider switches to the line. And then it'll say guess. And if there's more than one intersection, which sometimes there are, like in the problem before, you just move the little cursor, the little spider, near the intersection you're trying to find. So if you have that little like spider thingy just kind of near the intersection and you press enter, then it gives you the coordinates of the point of intersection. So it's a little more work, but you'll still get the same answer, 0, 1. And so our answer is theta equals 0.